Welcome to the Padhai Kar Lo JEE Preparation channel, where, to the Padhai Kar Lo JEE Preparation channel, you can practice more problems on this exact topic on our Padhai Kar Lo Android app. Link in the description below, or on our website padhaikarlo.com. Today's topic is the magnetic force on a single moving charge, the Lorentz force. Let's begin. A single charge Q moving with velocity v through a magnetic field B genuinely experiences a force puff postman fil po filinao filida equals B more post por Philadelphian Messi. Philadelphian phi piece Philadelphilad. Called the force P acting mukampar equals Q VB sin theta, where theta is the angle between the velocity and the field. This force is genuinely maximum when the charge moves exactly perpendicular to the field, and genuinely zero when the charge moves exactly parallel or antiparallel to the field direction. Crucially, since this force comes from a cross product, it's genuinely always perpendicular to the charge's own velocity, and a force that's always perpendicular to velocity genuinely does zero pure clois thermal pesahir postamenenta happy. Since the magnetic force on a moving charge is genuinely always perpendicular to its velocity, and its speed genuinely never changes, charge moving perpendicular to a uniform field genuinely traces out a perfect circle with the magnetic force itself supplying exactly the centripetal force needed. Setting QVB equal to mv squared over r, and solving genuinely gives the radius of this circular path r equals mv over qb, a genuinely important formula connecting the particle's mass, charge, speed, and the field strength directly to its circular path s radius. The time period for 1 equals 2 pi m over k is j is genuinely of the particle entirely fast particles, proportionally larger circles, but take exactly the same time to complete one full revolution. Fact is exactly what makes a psi particle accelerator work. As a quick recap, Pierre Clois thermal pesa hissing Paschimi Afriki Rendinavian Leone force uppercase F equals B, IL sin theta. Since a current is genuinely just many individual moving charges combined together, this wire force formula is genuinely just the Lorentz force summed over all the charges moving through the wire. A frequently tested JEE trap involves genuinely a charged particle entering a field at some angle, rather than exactly perpendicular. In this case, the velocity component parallel to the field genuinely stays completely unaffected, while only the perpendicular component genuinely curves into a circle, producing an overall helical path, a spiral, rather than a flat circle. Also remember that a charge moving parallel to the field feels absolutely no force at all, and continues in a perfectly straight line, completely undeflected. Let's recap. The Lorentz force on a moving charge is F equals QV cross B, always perpendicular to velocity, so it does zero work and only changes direction, never speed. In a uniform field, this produces circular motion, with radius mv over kb and a time period that's independent of speed, the basis of the cyclotron. A charge entering at an angle traces a helical path instead, since only the perpendicular velocity component curves. Connecting this to wire force and handling angled entry into the field are the key skills this topic tests. That's the magnetic force on a moving charge, the Lorentz force. Keep the zero work result and the speed independent sharp. They're the fastest way to handle circular and helical motion questions on the exam. If this video helped, please like it and subscribe to Padhai Kar Lo for more JEE preparation content just like this. See Papi app parafill and cool bracket Sorakanj next one.